Welcome to the first episode of Mathmeowtics. All right, so I'm going to be talking about in this episode, starting to introduce linear inequalities. The essential understanding that you need to understand is that a linear inequality is an inequality with two variables whose graph is a region of the coordinate plane that is bounded by a line. And each point within that region is a solution. What that means, and when we talk about a solution, that means it's true. Now, if we think back, and we've learned in the past, we've learned about a number line. And we've seen this before. I'm just going to draw a number line. Okay. And we have a number line. We have 0, 1, 2, and we have -1, and we have negative 2, and we have -3, and we have 3, and we have 4. This is a general number line that most of us are fairly used to. It goes from negative infinity to positive infinity. And some of us, many of us have seen this value where we have x is greater than equal to a value of, let's say, 2, or let's even say x is greater than -2. Okay, and we know that, let's say I'm going to draw this, I'm going to use a different color so I can talk about the two different graphs. So when we talk about x is greater than 2 and greater than or equal to, I'm going to put a circle there, and it needs to be solid because it can equal that value 2. Then I'm going to shade or draw an arrow towards the right because all the values, all the solutions to this inequality here, x is greater than or equal to 2, are to the right of our graph, and including that value 2. But our second inequality, where x is greater than our value of -2, so then I'm talking about this value here, okay? That is not including that value -2. That's only including the values that are greater than -2. So it would be talking about the way of the graph going this way to the right, because it's all the values of x that are greater than -2. Not so bad. We've seen this before. It's familiar. But now if we talk about it in terms of let me erase this. Hold on, I need to make it bigger. Talking about graphing that, okay? Not so bad. We know that a graph is going to look like this. Oops, let me draw a color. All right, make my thickness thinner. All right, we have a coordinate plane. We have x and y axis, okay? This is my x-axis, is horizontal, and as my horizontal left to right is my x-axis, and my y-axis is up and down. Then on the y-axis, we have all our positive values. Okay, so we have oops, let me do a different, hold on, I think I know what I did wrong there. Give me 1 second. I know what I did wrong there. Okay, give me 1 second here. I'm going to change color. Technical difficulties. Okay, now we're going to go positive 1, 2, 3, 4, 5. So this is 1, 2, 3, 4, 5. And our negative, -1, -2, -3, -4. And then our x-axis is going to be 1, 2, 3, 4. And we have -1, -2, -3, and so on. All right, now the problem that we had that we gave earlier was was x greater than or equal to 2, and we also had x is greater than -2. Now, when we talk about graphically, and we talk about x is greater than or equal to, or when we talk about x is equal to 2, that would be a vertical line, okay? Now, this symbol here, that means it can equal to. So instead of using a circle when we talk about a number line, we're going to draw a vertical line at number 2, and it's going to be solid. Okay, that's going to let us know that it's going to include that value. But now we want to talk about all the values that are going to be included, because in this value, x can be 2.5, it can be 3, it can be 4, it can be 4.5. All of those values are true. So we would do what we call shading. We would shade to the right of the graph, that's all, just like when we did on the number line. When we talked about that number line, and we had 2 here, and we had 3 here, and we had 1 there, and we talked about that value 2, and everything's shaded to the right. Not so bad. Now we're going to talk about x is greater than -2. Let me use a different color. All right, x is negative 2. Now look, it can't equal that negative 2 value, so instead of solid, it's going to be dashed. Now again, just like on the greater than or equal to 2, it's going to be all the values like negative 1.5, negative 1, negative 0.5, negative 0.75, 0, 1, 2, 3. So I'm going to shade my graph to the right. Pretty straightforward. Now this is going to introduce us into our topic of linear inequalities. Okay, I'm going to erase this so you can see it, what that really means. And again, this definition here on this worksheet or on this notes, it talks about the key concepts of the linear inequalities with two variables. Okay, it talks about here in, make this thick, a little bit less thick. When our line is dashed, each point on a dashed line is not a solution. So if I were to pick any point along here, so I'm going to pick that point that's on the line. That point there is, our x value is 0, and then our y value is negative 1. That is not, that will not be a solution to that inequality that we're given. That means that it won't be true. This is false. Okay, same now here. In terms of the solid line, each point on the solid line is a solution. And that's for a solid line is used for inequalities such as greater than or equal to or less than or equal to. Now, one of the ways that you can remember is that if it has this little line underneath our inequality symbol, then we know that it's going to be solid. If it doesn't, then we know it's going to be dashed. All right. Now, I'm going to just real quick talk about problem number 1 here in terms of identifying whether or not a ordered pair or a point. Okay, this 1, 2 represent a point on the graph. This also here represents a point on the graph. Okay, I want to see if either one of these are a solution to the inequality that I'm given. Okay, really simple. That x, this is x, this is y. That is the x value that is in here. This is the y value that's in here. This here is the x value. This is the y value that's in this point, or in this inequality, sorry. So my y value is 2, so I'm going to substitute that in for my y value, greater than, and then my x value is 1 minus 3. So 2 is greater than, 1 minus 3 gives us negative 2. 2 is greater than negative 2. Yes, this is true. So that means that this coordinate point, this ordered pair is a solution to y greater than x minus 3. Now remember, when we have an inequality, there can be multiple solutions. Now, when I'm going to check this next point on section B, okay, I'm going to plug that in. My y, so this is x, this is y. My y is negative 7. I'm going to copy down my inequality, greater than negative 3. X is negative 3 minus 7. So 7 greater than, so negative 3 minus, that should have been not negative 7. That should have been 3. That will give us negative 6. This is not true. Negative 7 is not greater than negative 6. So this is false. So on the coordinate plane, if I were to graph this inequality, this would not be true for our inequality that we're given. So this is not a solution. All right, pretty straightforward and simple. That's the intro of this. We will get into talking about problem number 2 and problems number 3 in the next video. I will see you on the next video. I look forward to seeing you. Goodbye.